Oppan Gangnam Style.
Hi, everybody. In this lecture, we're going to discuss the substitution rule, which is one of our very most powerful techniques for computing integrals. So the main idea is that we're going to take a difficult integral of f of x dx, and turn it into an easier integral of g of u du, by changing variables in a clever way. And one way to think about the substitution rule is it's kind of like reversing the chain rule. So it's easiest to explain what I mean by that with an example. So the chain rule tells us how to differentiate all kinds of functions. For example, d dx of the function natural log of x squared is equal to 2 times natural log of x times 1 over x. So what does that mean? That means that the function natural log of x squared is an antiderivative of this other function, antiderivative of the function 2 natural log of x over x. So using the notation of indefinite integrals, the integral of 2 natural log of x over x dx is equal to natural log of x squared plus c. Okay, so this is an integral that we now know how to compute, because when you do the chain rule, you can check that the natural log of x squared is an antiderivative of this function. And the main question is, what if we wanted to go the other way? What do I mean, go the other way? Well, maybe you start with a function like 2 natural log of x over x dx, and no one tells you ahead of time that you should check the derivative of ln of x squared. How do you know that ln of x squared is the right function to consider? What if we start with the integral of 2 ln x over x dx? The question is, how do you look for a function where you apply the chain rule and it gives you the derivative is the thing that you want to integrate? Okay, so that's the question that we're going to answer with the substitution rule. Look for a function where you apply the chain rule and get what you want. Okay, so the easiest thing to do is to start with an example. Let's consider the example of the integral of e to the sine of x times cosine of x dx. The idea here is that this integral kind of looks like the integral of e to the something d something. Right? It's not quite that. There's a sine x in the exponent and this cosine x here, but it kind of looks like e to the something. So what we can do is a substitution where we let u equal to sine of x. This is the hardest part of understanding the beginning of the substitution rule. In the original integral, we have a dx. So what we're going to do is let du be defined. This is a definition, is going to be the derivative of the function that we set u equal to. So it will be du dx, the derivative of this u with respect to x times dx. Okay, so there is a rigorous mathematical definition behind what this means. Let's just look in one example. So in this example, u is equal to sine of x. So du dx is cosine of x. And du is equal to cosine x dx. So I said there is a rigorous mathematical definition of what this is all about. And I'll say see section 3.10 on what are called differentials for details. But you're not going to need to know anything from this section about what differentials are in order to apply the substitution rule in this class. So you can just take this to be a definition of what du is when you write u equals some function of x. Du is take the derivative of the function of x with respect to x times dx. So why does that help? Well, now this integral of e to the sine x cosine x dx, well, sine x is equal to u. So this first term is e to the u, and cosine x dx is du. So this is equal to the integral of e to the u du. And u is just some other variable now. So what is a function whose derivative is e to the u? What's an antiderivative of e to the u look like? Well, this is just e to the u plus c. But our original integral was in terms of this variable x. So the answer we get at the end, we would like to be in terms of the variable x. But u is just equal to sine of x. So e to the u is e to the sine x plus c. Okay, so just to check that this all makes sense, we can now take this function that we claim is an antiderivative of e to the sine of x cosine x and check that it actually is an antiderivative. So here's a check. What happens when you take d dx of e to the sine of x plus c? Well, this is a constant function c, so the derivative is 0. So what you get applying the chain rule is e to the sine of x, because that's the derivative of e to the u. The derivative is e to the u. But then with the chain rule, you need an extra factor of the derivative of the inside function. So you pick up a cosine of x. So we see that this does work. E to the sine of x plus c is an antiderivative of the function that we started with. So in the next video, we'll see a lot more examples of how the substitution rule allows us to compute integrals that we didn't know how to do before.